Hello everyone. Today we are going to discuss our notebook number 2 in our lecture series called Python Libraries Introduction for Machine Learning. So you can get this notebook from the GitHub repository. I shared this link with you previously. You can go to the GitHub repository and click on the notebook number 2, and then you can also see the notebook, but you cannot run it here. So to execute the commands and this code, you need to copy the link and go to Google Colab, click File, open New Notebook, Open Notebook, and click on the GitHub tab. Okay, you don't need to sign in. Paste the URL on the search bar, text box, then click on the search bar. The notebook will be open for you in GitHub, so in Google Colab, and then you can go through the notebook. So last week we tried to cover first half of this notebook, but I will quickly go through. So in the first half, we are going to discuss about the Pandas library in Python, which is very useful library for data handling, especially for tabular data. So Pandas provide like a set of functions and classes to hold tabular data sets. Right? So we will discuss about how we can do that later, but basically what we are trying to do here is importing the Pandas library. So the abbreviation we use the alias for Pandas library is PD, same as NumPy, import as NP. So you first thing you need to do is you need to import the library. Okay. So this command will import the library into your notebook environment, and then you can use all of its functions and methods. Okay, so first of all, I'm going to load a data set, so which is a CSV file. So if you are not familiar with the CSV file format, CSV file is nothing but like a data set which is stored as a text file. And in a data set, we already discussed about like a table. So we all know about table, right? So rows and columns. So rows will be represented by lines in this text file, and columns will be separated out using commas, right? So each row, each cell will separate using commas. So that's the comma separated stand for. We call this file is CSV with the CSV extension, right? So the line break will serve as the row delimiter, and comma will serve as the column delimiter. Okay, so let's go back to the notebook. So this data set I downloaded from UCI machine learning repository, so you can also go there and read more about the data set and understand more than what I'm going to describe in the class, right? And also you can read about a paper using this data set. All right, so first task is to load the data set. So in Pandas library, we have a set of functions start with read. So if you noticed here, what we are using the function name read CSV. This function is doing nothing but reading the CSV file from your local folder. So if you have if you download this file to your local environment, you need to provide the file path, or else you can use the URL directly. So if given the file location or file path, you can read the content into a pandas data frame. The pandas data frame is what we are calling in Python as the class, or the object derived from that class which holds the tabular data. Okay, so we'll learn about data frames and its characteristics. So let's learn about how to load a CSV file into a data frame. So you need to execute this. So this will first of all I will try to erase our previous outputs and then restart the notebook. So that will be helpful for you to navigate through. So let me run this again, run this command. So what this command does is it loads the notebook, it loads the CSV file, and you can visualize first 5 rows of this data frame. Right? So we load the CSV tabular data into data frame, and we are looking at first 5 row. So that's what the head function in the data frame stands for. Remember, like I told you, like this is a data frame object derived from data frame class in Pandas. So this data is that object name. So that's the variable, and that object has attributes and methods. So head is a very useful method we will be using that will display first 5 rows given that given no parameters. Right? If you provide any parameter, if you want to visualize first 10 rows, you can provide how many rows you want to visualize in number of rows, and then when you execute that, you will get first 10 rows. Right? Similar to that, you can use tail, which stand for last 10 rows. So either you can provide a number. If you don't provide any number, it will give you last 5 rows. Okay. So this is like multiple ways you can see the data the rows in a data frame. If you want to randomly select a row, so you can say sample. We will discuss more about this sample function later. The sample function will get like a random do a random selection of rows in your data set, and you can visualize. Also you can provide in this case, if you don't provide any parameters, it will pull only one row, and if you provide any parameter, say like 10, it will pick 10 random rows from your data set, right? So named data here. Okay, so that's about like visualizing or checking on rows in a data frame. So that's what actually I would do first when I load a data set in Pandas data frame. I would check like a sample of rows, or like head, tail, or sample, and just to see whether your data set is loaded properly. You have all column definitions, and so rows loaded, and then data is like nicely displayed, right? So we need to make sure that, because it for some reasons is the source file can be corrupted, and your column row separators can be missing, so therefore you will load data incorrectly. So you want to make sure your data is loaded correctly. So that's one of the first thing you should do in any data related project. If you're using Pandas or any other tool, any other programming language, any other tool for data loading, you need to make sure your data is loaded correct. Okay. And here, you recall your understanding about the table, right? So this is how the data frame looks like, and you will see the columns and rows. So the columns in a data frame having column names as usual. Rows in a data frame are numbered, so you will see some numbers appear in bold in the leftmost side of the data frame. So those we call in the in data frame as index. So index is an attribute that stores an identifier for each row, right? So let's start from 0 like an array. So if you use the head function, you will see how the first 10 rows looks like. So the index start from 0 and ends with the n minus 1. N is a number of rows in your data frame, right? So that is how you can uniquely identify a cell. So you can say index 1 and column displacement. So this cell you can identify like. Okay, so same as the Excel, you do row and column identifiers to name a cell in a formula, or to extract values, etc. So you can do this in Pandas as well. Another thing I wanted to mention, so Pandas data frame, you can think like an Excel worksheet. Okay, so we will learn some of the operations how we can use them. All right. So I have some more like information you can read about each and every column in this data set. As I said, like there are multiple columns like miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and car name. So those are the columns. So let's look at like the data set definition. So this data set contains some information about miles per gallon, which defines the efficiency of a car, how many miles this car can travel given a gallon of fuel. Okay, and so the goal of this exercise or in the machine learning exercise to characterize a car, or we wanted to find out given other car characteristics such as cylinders, displacement, horsepower, weight, acceleration, model year, origin. Given those characteristics, we should be able to predict what is the miles per gallon. So we have a number of records from the cars. We historically take those characteristics. So by now you know what is characteristics using those characteristics, we should be able to predict miles per gallon. So how we do that? We know historically these cars with these characteristics had this miles per gallon. Someone did the experiment before you and collected data, and now you have the historic data set. So you're going to analyze this data set and build a machine learning model, and that model should be able to predict on a new car, so which is not part of the data set. So someone bought a new car into your model and input the characteristics of that car, and you should be able to predict miles per gallon for that car. Assume this is a problem. A car dealership wanted to put this model into their web interface, and so they wanted to use it by their customers when they wanted to buy a car. When the customer wanted to give the characteristics of their dream car, and they wanted to know what is the miles per gallon. So without testing on this car, so the customer should be able to find it using your prediction from your machine learning model. This is just a hypothetical example. This could not be very applicable, but let's try and see whether we can make a good model out of this data set. Right? So when you get such a data set, you should be, as a data scientist or machine learning engineer, whoever like dealing with any machine learning or data science related work, the first thing you should be very curious about the data you get. So some of the question you should ask is how many rows or records in that data set. So you want to know size of the data set basically, right? And how many columns. So that's the size defined, how many rows, how many columns. And any other way you can think of like size of the memory footprint, etc. So we will look into that in a later day, but today we are not going to discuss about the memory allocation for the data set. Then, but let's first look at the size. And then what are the data formats? So last week we discussed about the different data types and understanding the data, understanding whether categorical, numerical, whether it's an integer, whether it's a floating point number, whether it's a string. So there are different data types, right? Different types like categorical, numerical. If it is categorical, whether it's a binary or whether it's a nominal variable or ordinal variable. If it is a categorical, whether it's a discrete or continuous, if it is a numerical variable. So we wanted to understand those things. Right? So what are the data types? What data looks like, right? And then then we have to do a lot of understanding of the data. So I'm not going to list in this very introductory notebook. So we are going to discuss in detail how to use descriptive statistics, exploratory data analysis to understand data better, right? So we have to get like some basic statistics. So that's what we are going to use here, called like a describe function. I will show you how it works here, and we have to do that. But later we will do some detail work on that. And then we wanted to do what I will check like what type of machine learning problem is this. So we have now the data set, the customer having some discussion with us. Now we wanted to know what type of problem this is. So in this problem, I will simply walk you through, but we will come back to this topic again when we are discussing about supervised machine learning algorithms and regression algorithms in specific. But I will, in very high level, I will introduce you to the regression and machine learning models. Okay. So in this problem, we are going to predict miles per gallon. You will get to know. So let's first execute this two, and then you will have a better understanding. Okay. So miles per gallon is a floating point number which serves as our y variable or the target variable in our machine learning application, right? So we are going to predict this miles per gallon using other characteristics. So we have, like cylinders is an integer number, displacement is a floating point, like that, right? So we have other features or attributes you can call. From here onward, I will call in the machine learning context, I will call them as features. So therefore, we can stick with that word. So all other features will be here, and the miles per gallon is our target variable, so which is a floating point number, numeric value. So therefore, we can think of this problem is a regression problem. Okay, so we are not going to classify anything. We are not going to find out a class of this problem. So we are just wanted to predict a value. So this is a regression problem. Okay, and then we wanted to understand what type of problem it is, and then we want to identify x and y, obviously. So we already did that. So we know in this problem, so our customer wanted to predict the miles per gallon, and using the features, those are the x variables are cylinders, displacement, horsepower, weight, acceleration, model year, and order. Right, I want to drop this car name because we noticed in our data preview. So the car name is nothing but like a car model and the brand and the model number, etc. So I want to drop it first because if I want to create any variable out of this, I wanted to apply certain other techniques, which is not good for you to start in your very first lesson. So I'm going to skip the last column, but I'm going to use all the numeric columns in this iteration. Okay. All right. So then, like I said, we can do like some basic statistics for each and every column in your data set. So you can simply call another function in your data set. First of all, just pay attention to the shape and d types. Those are attributes of your data set, right? So data will show you how many rows and how many columns as a tuple, and the data d types will return you a list of items with the column name and the data type. So they both are attributes of your data frame. And the describe function will give you some basic statistics, right? Statistics such as how many counts, how many records you have, the values for miles per gallon, cylinders, displacement in each and every column. If you have any null values, you will see like less count compared to other values, right? So if you have any one or two null values in the acceleration column, so you will see say like two null values, or we call it none in Python. You have 390 instead of 392, right? So therefore you will know which columns are having missing values and how many total row count you will be having in this data set. You will get to know in the output of the describe function, right? And then other statistics like mean, median, standard deviation, we will discuss in detail. If you are not familiar with, I know some of you are having statistical background, so you know a statistic background, you know what this mean. If you don't have, or if you want to recall your knowledge, so we will have a separate lesson to discuss this, right? Mean is nothing but the average, standard deviation, minimum value. The percentile is 25th percentile, 50th percentile is the median value, 75th percentile, and the maximum for each and every numeric column you will be seeing here. Okay, so this will be a good preview of your data set, like the statistics of your data set, and will help you to understand the distribution of your data columns, right? So how the miles per gallon distributed, what is the mean and standard deviation will define you the distribution. And what are the minimum and maximum values, right? And also the percentile values also will be helpful to you to decide about these features, and how if you want to transform these features, so you can make some decisions by looking at this describe output. Okay. And so I'm not going to do any pre-processing task as should be done in any machine learning algorithm, machine learning project. So I'm going to use this data as it is, since this is a very introductory lesson. Otherwise, we have to do some data pre-processing to convert this data columns into like different format. Or so if it is numeric, probably if you wanted to convert into categorical, you can do that. If you want to scale it, you can do that. If you want to standardize it, we will discuss all of these things in one of our coming lessons. So those are like pre-processing tasks. If you have a data set, if you wanted to convert into different formats or different apply different transformations before you go into machine learning, you can do it in the pre-processing step. So I'm just trying to navigate you through the process we will be doing in machine learning application. But here I'm not going to do any pre-processing. So therefore, I'm just again like trying to execute the describe function, right? You can do this while we watching this video. You can do this with me in the notebook, and you can practice. So one of the advice I always give, try to experiment with the notebook. So you are going to break nothing. So you can write your own code, try out different things, right? And then you can experiment with it, get errors. That's how you can learn. In the third step, so we can explore the data set further. So one way to explore data set is, like I said, getting some statistics. Another way you can explore the data set is visualizing the data, right? So this actually should come here under explore data set. Okay. So first step is you can do the statistics, and then we will learn like few more ways you can do that. And then you can do like data visualization. Here I can use the scatter plot. So in a scatter plot, we can have, we all know what is scatter plot, I assume. If not, just read about it, but I will give you a brief overview. So you have x and y axis, and each dot in a scatter plot represent one value, right? So here what I'm going to plot, and the column values of cylinders against the miles per gallon, right? So each dot represent a value of the cylinder and miles per gallon. How it, this row this dot represent a row. In that row we have number of cylinders is 5 and miles per gallon is 20, right? Like that you have each row represented by a dot here or the circle. Okay, and then we can visualize what is the horsepower. So I will explain about the function after visualizing a few of these variables, right? So the horsepower, so miles per gallon against horsepower, right? So horsepower is the x-axis, miles per gallon is your y-axis, right? I'm trying to visualize miles per gallon as y-axis because that's our y variable or the target variable. So we are going to visualize that. Okay, so and then let's look at another one called weight, right? So how weight is can be plot against miles per gallon plot against weight. So you see like some interesting thing in this plot, right? So the cylinders and miles per gallon, you don't see any pronounced pattern. Someone can say it's slightly decreasing with the number of cylinders, right? The car efficiency is decreasing with when the number of cylinders increase. But here the horsepower tells you like a good story, right? So when the horsepower get increased, right, from 50 to 255, you see some pattern. Miles per gallon is decreasing. Yeah, but you see like the data is scattered heavily, but you will see some pattern, and same as that the weight. So when weight get increased, what happened to miles per gallon? Those things you can observe in a data visualization. So that's how you can visualize. Before you just jumping into machine learning, these things you probably need to do. Okay, so before we are going to plot others, so let's examine the function now. So in a data frame object data, it has a function or method named plot. So this plot is using a library function we all already know, the Matplotlib library. So the pandas, you have Matplotlib library embedded into the pandas library and implemented a version in it. And then the data.plot invoke that Matplotlib commands or Matplotlib methods to visualize your data set directly without explicitly calling Matplotlib, right? So you can simply call data.plot. And in a scatter plot, we are using a parameter to let this function know which type of plot you should be using. So there are multiple types of plots you can use: scatter plot, line plot, bar plot, pie charts, and area plots. Many other plots available in this plot function. So we have to specify which kind of plot you wanted to use, right? So the scatter is that kind. Okay. Then you need to you can interchange this parameter order, right? So you can have kind before x and y needed. So here what we will be providing, what is your x variable. So with the column name from your data set, name data, and what is your y variable, right? So this is what you will be doing here. So this function is very simply, you can call scatter plot, x variable and y variable. When you provide that, it will simply plot it. You don't need to write any more command. It's just this one line thing. You don't need to load matplotlib and use matplotlib. So you can do that, but this will be very easy, right? So let's look at a few more variables like that, how the model year. So how the miles per gallon depend on the model year. So you will see like slight increasing trend. When the car is getting newer and newer, the efficiency get increased. That's obvious. And also let's look at the relationship between miles per gallon with the displacement, right? When you plot miles per gallon against displacement. So if you wanted to know what is displacement, you have the Wikipedia link, you can read about it. So but we can see from this data, when you have like higher displacement in the cylinder, so you will get higher the miles per gallon. So lower the miles per gallon. Okay, and then so let's look at the acceleration. So the column acceleration, when the acceleration increase, what is going to happen is miles per gallon has like slight increase in trend. So when the acceleration is lower, miles per gallon is lower. When acceleration higher, miles per gallon is higher. But we cannot directly say it's always is a relation. But so you will see like in overall you will see a pattern, right? Okay, so these are like some of the observation you can do. You can find out relationship between two variables. We will learn more like explicitly about this analysis, how we can do that, what we call this type of analysis. We call a bivariate analysis. How one variable related to other, we will do like correlation and some other techniques. But here you can get like a simple visualization to understand the pattern, how the one variable depends on the other, right? This is our target variable, y variable, how it depends on the others, right? Okay, so this is about the scatter plots, how you get to understand some relationships, and then how you can use the histogram. So in the histogram is another powerful plot. If you have a numeric variable or numeric column, you can apply histogram. For example, the model year. We want to know how this model year values distributed. So that you all know what is histogram. If not, just read about it. I'm going to discuss that in detail when we are discussing exploratory data analysis. So in Pandas data frame, what you need to do is you have to get a column out of it. So this we call a series, right? So before we jumping into that, so I'm going to uh, show you that. So the model here is a column. So if we take that out, same as you do in a dictionary, in the key value in a dictionary, right? So in the data frame, you can take the model here out with the square brackets, indicates the data frame. You can get the boundary of that, and then the model here is your column name, like you are using the index of an array or a key value in your dictionary, right? So this will return you another object called a name like series, right? So I forgot to mention earlier, so data frame has columns in pandas where each column will consider as another object. So that object we call a series, right? So in another way we can say a data frame consists of a collection of series. So series is a column. So in this model year column, you will see the column values are displayed with the row index, right? So each series will have a row index and a like set of values, right? These columns we can access separately in a data frame by calling it like that. Data frame name, and as index the column name. Then you can apply the plot function for those columns as well. So in this we are doing is we are applying plot function and we are selecting kind is to indicate that we need a histogram. So this is how the model year distribution looks like in the histogram. Right? So we'll see this data is spreaded during the times from 1970s to 1982, 1970 to 1982. And so you'll have like a number of cars. So we found 300. I think the number of cars is 392. We have records coming from 392 different cars and how they distributed by the model year. Right? Here, for example, we found like here like between 70 and 71. So basically 70 and 71, we have 55 cars. Right? So like that, we will get to know how the data is distributed for this model year variable. Another useful plot we will be using in Pandas Matplotlib, so will be the box plot. So we will learn in detail about this box plot later, but in brief, so what it will shows you another way of visualizing the data distribution. So it will give you an indicator of what is the median value and what is the 25th percentile of your data set of your values in your column, and 75th percentile, and we also can get the boundaries of the so we will get to know whether there's any outliers in this data set. So the box plot will be very useful tool to find out whether your data set or the So we will discuss about this detail as well. But simply this box indicate like if your boundary of your values within 25th percentile to 75th percentile. The green line in this at the center indicates the median value, right? So we will get to know about these values. So about like 2,700 something will be your median value. So actually 2,803, that indicated by your green line. You will see the level here, and your max weight is 5,140. You can see here we don't have any outliers, therefore your max and min, we call these are whiskers. So we'll get the boundary of your distribution. If you have any outliers, say like you have someone make a mistake and then add the data point value for weight of this in the weight column as 10,000, 20,000. So that will flag as an outlier. It will display as a dot somewhere here, but you will have the boundary of your data set and the outliers. If you wanted to get the median value explicitly, mean, max, median from any column, we will also discuss this in detail. You can use these functions, like so median, for example, you will get this, so you can get minimum value. You try out this while you are working with me, and then get the max. Okay, so this is how you can practice max, mean, and then mean, right? So many other functions available you can apply on a column level to get some statistics and to get some count. You can also get some of weight you need. So try this out in Notebook. All right. So this is about like getting to know about the data, exploratory data analysis topic we will touch in very detail. But basically some functions I just want to get you introduced to, and then get familiar with the pandas of those functions. And then we will discuss about the Scikit-Learn library. And in the Scikit-Learn library, we will be just going through the model building process. I'm not going to discuss in very detail. I'm going to cover it in very high level. So to get you familiar with the library. So Scikit-Learn library also very useful in this, not only this course, but your entire machine learning work, right? So this provide like set of non-neural network type machine learning algorithm. I think almost all the machine learning algorithms you can use in an industry or any application are now included in the Scikit-Learn library. So this library is maintained by both academic and industrial professionals. So they are open, free and open source. They maintain free and open source organization. So the Scikit-Learn is also provided for free and open source basis. So you can go to their website, and there are many tutorials, examples. You can download data sets, and you can try out. Their website is very helpful. So that's what I wanted to say. Just refer to their website if you have any problem. They have a nice documentation. Some examples when we finish when you are finishing the lessons, you will get to know about these terms and how to read this properly with the technical context. After that, this website from their package maintainers website will be very helpful thing to refer, right? So go to this link. Both Pandas and Scikit-Learn both have like a good documentation, well maintained website with tutorials, demos, etc. So refer to that. Okay. So in the Scikit-Learn library, let's try to use the Scikit-Learn library to build a machine learning model as we move progress, right? So in our very first few lectures, we learn we can interpret a model as a function, right, which accepts features called x variables, which predicts the target variable we call y variable. And the feature vector we call a set of features. So if we put like feature 1, feature 2, feature 3 like that in this example, so like miles per gallon is our y variable. So I usually should ask you the question, but since this is a recorded one, I wanted to give the answer to you as well. In this problem, y is your target variable, which is our miles per gallon. That means your column. So let's without going up, so let's try to use another function. All right, so data dot columns. Okay, so this is and how we can get the columns, a list of columns in this data set. So miles per gallon, cylinders, displacement. This is like you can get a list out of your data frame. So if you whenever you wanted to visualize or see the column names, you can call data.columns, and attribute will give you a list of columns, right? So in this example data set, we will be using miles per gallon is a y variable, and we will be using cylinders, displacement, horsepower, weight, acceleration, model year, origin I'm going to drop for now, and other variables to uh, be used as our x variables, right? So those can be your x1, x2, x3 for the feature vector, right? That makes your feature vector. If you take a row out of your data set, so that row will be one dimensional as a vector. So the values of that row will consist of these the values of this each and every column, right? So those makes a feature vector. And then target label we already discussed, and then the model function, we can think of the model function looks like, so y is your output, and the function is a function of your feature vector. So let's look at how we can implement this in scikit-learn. So first of all, like pandas, you need to import scikit-learn. So here I'm not going to import the entire library. I'm going to import a submodule called like linear model. From scikit-learn, I'm importing linear model. Okay. So this module has all the required classes and methods in those classes, and some other code like code fragments to implement linear model, right? So this has like number of different linear models. I'm going to use linear regression. So this is how I can. So let's try to execute this. So import the scikit-learn library into our environment. So first you need to do that, and then create the model object. Now recall, like in Python, everything we use in Python are objects. So data frame is an object. I call like series is an object, which we know like column of a data frame, and everything is an object in Python, including functions and variables. So you can always have methods and attributes for each and every variable, function, and everything. So here, first we need to create a model object, right? So how we can create in the linear model, the submodel from the scikit-learn, we already loaded, and then we call linear regression class. This is the constructor of that class. We are creating the model object from the linear regression class. So this model will be created here. I'm going to execute and just print the model. So the print model will simply show you like which class it belongs to, like the class name and the constructor method as a string. But if you just print an object, so this is what we get. So we know we created a linear regression model. Okay, now we have a linear model object created, which is like linear regression model. We created as the model assigned to model variable. So we'll name by the model. So this is your model object, and we verified. We created a linear regression model object, and then we decided to use one feature in this iteration. The feature is weight that we are going to use now, and your y variable is miles per gallon in this data set. I'm going to have like create like two string variables, y actual and y predict, to hold the column names. The y actual is the column name in your data set, and in future when I predict for the same data set, when I apply the model and predict miles per gallon using the model, I'm going to name that column as predicted mpg. So this variable I'm just keeping it for future use. Okay, so now let's look at how to train your model. So the linear regression model, we know from our very first week lesson. So the linear regression equation is you can see something like this. So y equals a0 plus a1 times x plus a2 times x2 plus a3 times x3 and so on, and an times xn. How many number of unknowns will be decided what is the value of n, and you will have a constant for each variable, and you have an intercept which is like a0, right? So if you have only one variable, your linear regression will be like a equation for like a linear fit, as you've seen in this example we discussed in the very first few class. At your equation will be like y equals mx plus c, which is your family equation from your previous studies. So m is the slope of this equation, c is the intercept, right? So we learned like this is a special case with only one variable. When we are talking about linear regression with multiple variables, so the equation will become in a generalized form. So it involves a0, a1, a2, a3, and an coefficients, right? So instead of m, a0 becomes c. All right. So now our equation is like y equals a0 plus a1 x. So what is our x now? X is our weight, and what we are trying to do in the model fitting or when in terms of training, what we are trying to do is we are trying to optimize the values of a0 and a1. We are trying to find values for a0 and a1, which gives you the best result for given x variables, and also we know the y variables, which is like miles per gallon given weight, right? So using those known values, so we are trying to get values of a0 and a1 for that data set we are going to use. So let's go back to our notebook. So the model fit function in scikit-learn, so the model is our object name, so you can give any name, so you don't need to have the model as a name all the time. So you can give LGR or logistic regression model or whatever the name. You can even say like cat or dog to name the model, right? But the fit is a function of that model object, which scikit-learn provides this fit function as the function we use for training a model. So this fit function is used in almost all the scikit-learn models, so to train the model using data, right? So if you are using a supervised algorithm like logistic regression, linear regression, which is what we are using right now, you need to pass two parameters. So first parameter is your features, set of features, and the second parameter should be your y variable or the target variable. The known values historically, you know these values for supervised learning. What happened given these features? This was your target variable value, right? So those are the data historically someone created for you, or you created, you collected. Okay, so so we are passing those two parameters. So the first parameter we can pass as a two-dimensional array or a data frame. Second parameter you can pass as a column or a series in your data frame or one-dimensional array, right? So that's your y variable. So here we are passing the data our data set we named as the data frame name is data, and we are passing all the x variables. But let's look at what are the x variables. Only one. We are passing weight as x variable, and then we are passing y actual or data y actual as like miles per gallon for your y variable. So then when we execute this, so your model is getting trained. Okay, and then when your model get trained, so now your model is ready to apply into a new data set which you don't know the y value, but you know the features. Then you can predict what the y value should be. But in this exercise or any other machine learning model, you have to test your model. So you are training your model with a data set with known y values, and also you need to apply testing on the same model you train on another data set which is not being part of the training data set. So this concept we are going to discuss later when we are discussing more about model training and evaluation. So we will come back to that. But for now, just keep in mind. So we like a teacher is giving a test to a student, right? We wanted to give a test to our model. So in this teacher student example, a teacher is teaching like every day, and every day so teacher will give some quizzes to the student who get trained, right? But if the teacher gave the same questions he or she asked during those daily quizzes, the final exam, will it going to work? So most likely student will remember the answers and student get familiar with those questions, so he can answer even without understanding the content. So what we need to do here is we wanted to know whether our model trained well. So therefore we wanted to give a data set with y value is model don't know the y value, but we provide only the features, and then we try to predict y values from the model, and then we know, but we know the value, the correct answers. We compare the what model tells us about these y values and what we have. We can compare, and we can evaluate how good your model predicts on the testing data set, right? So therefore, remember, like these two terms, we are using training data set for training. So here you can think of like this is your training data set, and we will use a separate data set for the testing. But in this example, I'm not going to do that. I'm going to use the same data set. I'm going to train with the same data set, and later I will be using the same data set for the testing. All right. So let's go through these steps, and then let's understand the model a little bit better. Okay. So we have like we run the model fit. So we completed this step. So we fit the model or we train the model. And then what we need to revisit to the slide I wanted to show you. So what we need to know is whether your model is trained. After your model get trained, we wanted to know what are the values of A0, A1, A2, and A. In this case, you should have only A0 and A1. Right? So let's look at your model and let's find out what are those values. So in Scikit-Learn model, there's an attribute after you train. The attribute names dot .cof underscore. So this is the attribute. So this attribute will give you all the coefficients of unknown. Right? In this case, you have one unknown. You should have one coefficient. So the intercept, so A0 in this the equation I showed you in the slide. So the intercept is what you can get from the attribute intercept underscore. Okay, so the model is your model object. You can have any name. Again, you can have any name. So this is just a variable name, and then variable holding the model object. And then the model dot intercept underscore, this is the attribute. You cannot change this. This is coming from scikit-learn. Model dot intercept will give you the value of intercept. Then we know how to reconstruct this equation if needed. But you don't need to reconstruct this equation. Scikit-learn model provide you a way you can use this equation without writing any code. You just need to provide x value, and then it will compute y for you, right? So, but what we found out is what are the values of A0 and A1. So if you have multiple variables, you will get for the coefficient underscore attribute, you will get A1, A2, A3, and up until AN. How many number of variables are you using? Okay, so let's run this cell and see what are the values. So one more thing I wanted to do it before. So we found the coefficients and intercept. So now I wanted to create a data frame using those coefficients. That data frame contain all the features we are using, and then their coefficients as a table, right? So this table is useful if you have multiple features, but right now in this iteration we have only one variable, but still you will see what is the benefit of it. Let me execute this, and then I will explain a little bit about this data frame constructor. Okay, so now you see after we execute this, we got the feature name weight, and we know the coefficient like A1 is this negative 0.007647, and the intercept is 46. Okay, so this is the value we get from the model train. Okay, so let's look at the data frame constructor. So here I'm constructing the data frame from two lists available in my code. So the data frame constructor you can call like pd.dataframe. You need to pass a parameter named data. So you can there are multiple ways you can construct. We will look into those when we are discussing more about the pandas later. So in this case, I'm passing a dictionary of columns. My first column is features, so that's the column name as the key in this dictionary. You're now familiar with the dictionary from our previous week lesson, and the key is features, which will become your column name, and x is a list or array. You can have any collection object, should be one dimensional, and then that will become your column values. So in this case, the x will contain only the string value weight, right? If you have multiple variables, we will see in the bottom of this notebook, you will have more feature variables into the list. And the coefficient is also an array returned from the model.coefficient. It returns the coefficient variable, and that is also an array. you are creating a new column called coefficients, and as the values you are giving the values of the coefficients array. Okay? So these two will become two columns in your new data frame. So this is how it looks like. The intercept is nothing but you don't need to put into the same table. If you want, you can do that as well. But here I will just display as a separate line. The intercept equals 40. Okay. All right. So that's how we used only one variable and how we trained a model using one variable. Okay. So you have some notes in the notebook you can read in your time. You can okay. So now we have a trained model, and now let's do some testing with the model. Right? So let's assume we have a car. We don't know what is the miles per gallon or the efficiency of that car, but we know the car weight is 2,500. Okay, that's the test weight. And then what we are trying to do is we are trying to predict the values of miles per gallon for this car. So given the weight, so you need to pass the value as a parameter. So you should pass a two-dimensional matrix, even you have only one column. So when you pass test weight into the function name predict in your model object, so whatever the name you will be using, you should have a function in your model object. You should have a function predict. Predict also a function used by many scikit-learn models. You will see classification, regression, clustering. So we use this predict function. So this predict function is doing what it is doing is it's simply predicting the value. So it's simply predicting the y variable. Okay, let's run this through and see what should be the result. Okay, so it will predict miles per gallon for this car given weight using the model we trained earlier is 27.098, right? So this is our predicted value for this car. This is how this model is being used in the application when users say, okay, I have a car with this weight. Okay, so then your model should tell, okay, this is what I know from my historic data, the training on the historic data. Given this weight, your car, I'm predicting your car, my miles per gallon in your car should be 27.0. Okay. So let's predict on the test data now. So like I said earlier, I'm not going to use separate test data set. I'm using the same data set, which I'm trained, which is not what we should be doing actually. But in this exercise is just to get you familiar with the scikit-learn framework. Therefore, I'm not worrying about that. I'm using the same data set for testing as well. So now I have the model trained. Instead of giving like a one value, I'm going to send the entire data set or the entire data set with only the feature we will be using. So data X is the part of your data set with feature column only. And I'm passing to the same predict function, and it will return an array or with the predictions, right? So that array I'm going to pass into a new column in my data set, so which I call y predict. So I remember the variable I created above is a string variable y predict, because I wanted to rename this predicted value column as predicted underscore mpg, right? So instead of retyping this, I'm going to reuse that variable. So this y predict will create a new column, and then that column, let's print it for the clarity. We can print it here, and what is y predict variable holds. So it holds the, so I think there's a typo. I will correct that. Predicted per gallon. Okay, so I will do this here. Okay. So let's run this. Okay, so now we have our data y predict we created, and then we can calculate the difference. So new column is y predicted miles per gallon. We know the difference between predicted value and the actual value will tell you something how good your model is, right? So let's calculate the difference. So I'm creating a new column. So this is how you create a new column. Even the previous one also, you can get an example how you can create a new column in Pandas dataset. Same like an Excel, you can create a new column with calculated column with some equation, or you can just type in an Excel worksheet. But in the pandas, we can assign a column name and then add an array or a result from another operation into this new column, right? So what is the operation is your y actual column minus y predict column will be your difference column. So this is what you right? So y actual is actually is my mpg and y predict is the predicted mpg. Okay, and the difference is simply the miles per gallon column minus predicted miles per gallon. Right? Same as the Excel, you can subtract this value by this value and will give you the difference. So this is how you create a new column. And then we don't need to we don't need to print or visualize all the columns. So if you wanted to visualize part of your column, you can name which columns you should be seeing in the output. You can pass the list of columns. Remember, list of columns you can pass into the square brackets in your data frame object, and then it will limit the columns you will be displaying. So we only wanted to see these three columns, and this is how we get that done. Okay, so now you see the three columns: miles per gallon, predicted miles per gallon, and the difference between them. This guy like is very off, but like some of them are like very close, right? So this is a little bit far away, but it looks decent. But this is going to be like a big problem, and this is like too high, right? So the prediction is too low from the actual value. The difference is high. So like that, we can have an idea, but we have to have some way to quantify it, right? So by visual appearance or by guessing the not guessing but seeing the number, you can have an idea, but we have to quantify as a whole. Like we have 392 predictions, and we know like the difference of each. So we have to have a way to quantify that result. So that is how we do the evaluation, and that is why we need to do evaluation. We can, for the regression model, we can use like different methods to evaluate the model. One method is mean square error, and another method is coefficient of determination. We call it like r square. If you did any of the statistics class or any science class, you know what is r square of a fit. I'm not going to discuss this in detail today, but we will be discussing them in detail. What are the equations we are using to do this computation, and what are the good values, what are the bad values of each of these evaluation models, not only for regression and other types of models in that lesson when we are discussing model evaluation as a separate topic, right? So, but today I just wanted to introduce you how you can do that and get familiar with the Scikit-Learn library. All right. So before we going to use these two methods, so let's try to visualize how your predicted value and actual value will differ. Right? So what we can do is we can plot using Matplotlib. So now you must be familiar with the Matplotlib library, and this is how you can import Matplotlib. And this is nothing but you are telling the notebook, I wanted to see. This will be very helpful when you are running this in a local Jupyter Notebook environment, because when you are running in local Jupyter Notebook environment and in the default settings, if it is not in line, you will pop up another window with your plot. So if you wanted to plot in the same notebook, you can say matplotlib inline. These are called magic functions. So if we get time, we can discuss, but you can read more about these magic functions in matplotlib. So you can say inline. So there are other options as well. And simple matplotlib plot. So now I introduced you how you can use Python pandas plot without explicitly loading matplotlib, but here what we are using is we are directly using matplotlib without any support from pandas, right? So we are using the matplotlib or the pyplot submodule in matplotlib, which supports all the plotting functions. So plt.scatter, we choose to create a scatter plot. You need to pass x variables, like set of x variables, and the corresponding y variables, right? So basically the x variable set and y variable, and will each dot or each circle in this plot represent a row or a data point, right? And what is your x variable here? And that is your actual value, miles per gallon. And what is your y variable is the predicted value, right? if your model is predicting very well, the predicted and actual should follow like a nice line. But in some situation it's not the case, right? So you will have some scatter plot here. So you have so data is dispersed. So you will see it's deviating from a linear trend. What you can see when the value is getting higher, the higher the miles per gallon, your model is not performing well. So that's what you can immediately notice. So this is like a visual observation how good your model works. What you can tell about your model is your model works well for low miles per gallon range, but when it is above 30 miles per gallon, your model is not performing well. Okay, so now let's look at this is a visual inspection you can do. We can also look at in the using the proper methods of like evaluating models with the proper quantification, the mean squared error and R score. Both are available from Scikit-Learn metrics submodule, Scikit-Learn library metrics submodules. You will say the mean square error and R2 square. Both are functions, and you can use directly with your results. So if you use mean square error, you need to pass your actual variable or the column from your data set containing actual values, and column from your data set with predicted values. So you need to pass into the mean square error function. It will calculate the mean square error. Okay, and also you can use the root mean square error. So you see the mean square error. So the error is the difference. You square it and find the mean value. You get one value, and since it is squared, so your unit of this mean square error is also like squared, right? So if say like if your measurement is miles per gallon, uh, let's take like a simple one. If your measurement is meters, so mean square error is the value is in square meters. So you need to get your mean square error or your quantification of the error into the same unit as your measurement. So then you need to get the square root. So for that case, we're going to use the square root. So what we can simply do is you can take the square root of mean square error to get the root mean square error, right? That's simple as that. So we can execute these lines and calculate these values and see what are the mean square and root mean square. And then what about the R2 or R2 score or the R square value or coefficient of determination? Same way, you need to pass your actual column and your predicted column, and the function R2 score will compute the R square value. So let's execute this and see the result. The mean square error is 18, root mean square error is 4.3, and R2 score is 0.69. So little about these values. So what our goal is in machine learning training, our goal is to minimize error, right? So that's our goal. We wanted to have a good agreement between actual value and predicted value. And then if we talked about R2 score or the R square value, so R square value close to 1 indicates your model is performing really good. So if R2 R square value is 0.99, that means your fit is really good. So if it falling below values like 0.5, 0.4, 0.3, that means your model is poorly performing, right? So you have to do something. This model is roughly like 0.7. So it's kind of in between. So we should think of like improving that, right? So let's see like how we can do that. Okay, so now you know like another step of machine learning model building is the evaluating the model is also important, and we want to use some quantification methods to do that, and based on that we will justify whether our model is good or bad, how much effort we need to put to improve that. All right. Okay, so then how to improve the model? So in this case, we have a way to improve the model that is by adding more features. So adding more features is adding horsepower as a new feature to the weight. Earlier we use only the weight, and now we are adding horsepower. So let's use the model fit. again with two variables as our feature data set or the feature input values, and then we keep the same actual, so we cannot change it. So that's why actual is always miles per gallon. That is our target variable or the variable we're going to predict, right? We are improving the feature data set. And so let's run this, and then when we run this, it will fit your model with two variables, and then your model, what our assumption is, your model should get improved. And then what we will be following is the same thing we did earlier. So get the coefficient, list of coefficients, and the intercept value, and we're going to create a data frame from your coefficients, right? Right now you will get like two rows in your coefficient table, and you will get the intercept value. So let's run this and see what is the output. Okay, so now we see like a resulting data frame with features weight and horsepower. Their coefficients will become like the weight will get 0.005794, horsepower will get minus 0.47303. Right? So this will become your A1 times weight, A2 times horsepower. Right? The coefficient of the horsepower is this. Right? And the intercept value is 44.6040. All right. So now you have like an equation with one more term than what you had earlier. So you have A0 plus A1 x1, x1 is weight, and plus A2 x2, x2 is horsepower. We know values of A0, A0, A1 and A2. All right. And now let's apply the same method, like the predict method, to predict on in your data set using new model we train. And then let's find the difference, and then we can also plot the agreement between the predicted value and the actual value. So let's when we do that, so let's execute that and see how your model is. Okay. So we have the same issue, the higher miles per gallon from the non values, the higher miles per gallon. The model is not predicting well. But let's see. But you see the data is less scattered, right? So the data dispersion is less, right? So you are seeing some improvement visually. So you are getting along a line, but this is not perfect. So let's use our methods, the evaluation methods, mean square error, root mean square error, and R2 score, and let's see how it looks like. It improved a little but not much. So from what we had was 18 4.3.69. So here we get like the R2 square got improved little bit, and root mean square a little bit. So our goal is to remember, our goal is to minimize this value. Mean square is also got lower than earlier, right? Not as we expect. So now let's add another variable. So this is what we keep doing. So this we are what we are doing is we are adding one variable, another variable, and see whether we get any improvement, right? So in this approach, when we add a variable, if your model is not improving, instead of that, if the performance, your R2 score or the root mean square error get decreased, that means the new variable we add probably is not going to work. So therefore we have to do some other steps in order to take care of that situation. Sometimes we need to take the new variable out and retain the model. And there are many things we will be discussing in the feature engineering and model evaluation together later. Okay, so, but now we keep adding new variables. Now let's add the model here now. I don't want to repeat again. So the steps are here. Like you define your feature variable feature columns, right? 3 columns now, and you're training your model and getting your model coefficients, right? So now you should have A1, A2, A3 for each of these features, and then the intercept value, which is A0. And using those values, you can create a data frame, a result data frame, and then you can also plot your actual value and the predicted value together, and then we can apply the mean square error, root mean square error, and R2 score to evaluate your model. So I'm going to run everything in one cell because I don't want to run step by step anymore, because we did like twice. Right? So only difference is adding a new variable called model here. So I'm running everything at one time. So now we see a big improvement, right? So adding three variables, adding one more variable. So now we have three variables. Each variable we now find the coefficient. So little different, not little, like a big difference from the previous one. And the three coefficients we know, and the intercept we know now. And also you will see now your model is getting along a line better, and even for the higher miles per gallon, it's predicting good, but it's still not perfect, right? So now we are still with three variables, right? So let's see what are the evaluation results coming. So mean square error from 17 to 11, which is like a big improvement. So remember, our goal is to minimize minimize the error value. And the root mean square error also, obviously, it's the square value of the above decreased, and the R2 score for the R square value from 0.7 to 0.8, which is a big improvement, right? So that means adding the new variable model year worked well. Okay, so then we can repeat this, adding another variable, another variable, another variable. We can keep doing that. So now let's use all the variables. You can practice in your own, adding like another one variable at a time, or having a set of variables and having a different set of variables. You can experiment with the code. You can simply delete this list some items from the list, and see how your model improves. So this is one of the exercise probably I would like you to carry over. So, and selecting features and finding out the best feature set your model is getting trained. Okay, so now here I'm using all the features available and train the model, basically following the same steps. I don't want to repeat, and see what it looks like. You'll see like there's not much improvement, but you will see one thing, your line is getting more clear, more pronounced line than using three variables. That's why I say, like, you can experiment removing some columns or pop some features, and retrain the model and see whether you can improve the mean square error. Okay, so reduce the mean square error, or improve the R2 or the R square. Okay, so that's for you. That's for an exercise for you. And also, like, now you can focus on our coefficient list. So we now have like 6 different features we used, and we know coefficients for each feature, right? So weight, if you say x1 is your weight, this is your a1, x2, a2, right? Like that, you have all the coefficients, and you have the a0 value, which is the intercept, right? So now let's look at how this we can construct that equation. So instead of a, I am using c is here. Like, it's okay to use any value. So it's not like rule we should use a1, a2, a3. You can use anything for the coefficient. So here I'm using c1, c2, c3 as the coefficient. And the equation, the regression equation for this problem, with all the variables we used in the last attempt, it looks like this: intercept plus c1 weight, c2 the coefficient times horsepower, c3 times model year, plus c4 times cylinder, c5 times displacement, c6 times acceleration, right? So this is your regression equation for this problem, using all the variables we used in the last attempt, right? If you apply the values, so I think the values below will be slightly different from what you had above. Okay, so it should be, yeah, you have like pretty much. So you get like negative 14.53 times this coefficient weight, this coefficient horsepower. So what do you need to know from here? Say like a new user, say like you implemented this model through a web interface. So that the web interface accept user input to provide weight, horsepower, model year, cylinders, displacement, and acceleration. Those six variables. So you're asking user to provide those, and based on those values, you can apply this equation and simply compute miles per gallon. In Python, if you use Python in this web interface for the backend calculation, you don't need to create any equation, but you can use the model we train, and that model will simply invoke you can call the function the model.predict, and send those values in, right? So this is basically what you will be doing in the machine learning model when you are deploying into an application. Right? So you're building the model, you are saving the model as a model object as into file, and then you are plugging that into the application. Then application will load the model object, and based on the user input, it will compute the predicted value and then return the predicted value. That is simple as that. All right. So this is the end of the notebook number 2, Python libraries introduction for machine learning. I just wanted to get you introduced to two main libraries, Pandas and Scikit-Learn. We will be heavily using in our future lessons for our machine learning activities, right? And also those are like industry standard machine learning libraries, the Scikit-Learn, and the Pandas is another industry standard Python library used for data manipulation, handling tabular data. All right. So if you have any question, you can let me know in the chat during our class time, or you can send them as a message later. All right. Thank you for having your time listening to this, and we will see you in the class.